Have you ever really thought about how your body stays warm even when it's freezing outside? It's pretty amazing, right? It's not magic. It's actually a complex internal furnace. So today, we're diving into a fascinating medical riddle that's going to help us unlock the secrets of that very furnace.
Okay, so here's our puzzle. Picture this. 4 different people show up at a clinic. You've got someone with high blood sugar, another with an underactive thyroid, a third with Cushing syndrome, and a fourth with heart disease. Now, one of them is at a much higher risk of their body temperature dropping to dangerous levels. The question is, who is it? And, more importantly, why?
To crack this case, we've got to go back to the basics. Where does our body heat actually come from? Well, the answer is deep inside that internal furnace we were talking about, a process you've probably heard of called metabolism. So let's think about your body like it's a high-performance engine. Your metabolic rate, that's just how fast that engine is running. A faster engine is going to burn through more fuel, the food we eat. And as a byproduct, it just naturally throws off a ton of heat. A slower engine, on the other hand, might be more fuel efficient, but it also runs a whole lot cooler. And this brings us to the one crucial rule you really need to remember. It's simple. A higher metabolic rate means more heat. A lower metabolic rate means less heat. That's it. It's a really simple but powerful relationship, and it is the absolute key to solving our puzzle. So, what's actually controlling this internal engine? Who's in the driver's seat? Well, it's a super complex system, but for our puzzle, we're just going to zero in on 2 key players. A pair of glands that basically act like your body's thermostat, turning the heat up or way down. Okay, first up, we have hypothyroidism. This is what happens when the thyroid gland gets a little, lazy. It's underactive, so it's not producing enough of these 2 hormones called T3 and T4. And these hormones are basically the green light for our cells to start burning energy. When you don't have enough of them, the whole system just kind of slows to a crawl. And then on the complete flip side, you've got Cushing syndrome. This one involves the adrenal glands and a hormone called cortisol. In this case, the body is just pumping out way too much cortisol, which has the exact opposite effect on our internal engine. All right, so here's where it all comes together. Let's put them side by side. Hypothyroidism with those low T3 and T4 levels is like slamming on the brakes of your metabolism. And what happens? Heat production just plummets. Cushing syndrome with all that extra cortisol is like flooring the accelerator. The metabolic rate skyrockets, and so does heat production. See? They're basically hormonal opposites when it comes to your body temperature. Okay, we've gathered all our clues. We know about metabolic rates, and we've seen how these 2 conditions can totally throw that rate out of whack. I think it's time we put the pieces together and finally solve this thing. So let's go back to our lineup of patients. We have the person with high blood sugar, the one with an underactive thyroid, the patient with Cushing syndrome, and the one with heart disease. Knowing what we know now, who is the most at risk for hypothyroidism? And the answer is the 55-year-old woman with hypothyroidism. Yep, it's her condition that's dialing down the thermostat on her internal furnace, leaving her really vulnerable to the cold. Let's just trace that chain reaction, step by step. It all starts with hypothyroidism, right? That leads to low levels of T3 and T4. This directly, and I mean directly, slows down the metabolic rate. That, in turn, means way less heat is being produced. And the final result? A high risk of hypothermia. It's a total domino effect, and it all kicks off with that underactive thyroid. So you might be wondering, okay, but what about the others? Well, the patient with Cushing syndrome, like we just learned, has a totally revved up metabolism. So if anything, they're producing more heat. And as for high blood sugar and heart disease, look, they're absolutely serious issues, but they don't directly slam the brakes on the body's heat production in that same way. And this really brings us to the core takeaway of this entire explainer. This quote from the source material just says it all. Anytime the metabolic rate decreases, heat energy production is reduced. That's not just a guideline, it's pretty much a fundamental law of our own biology. So there you have it. We've cracked the code. This whole intricate dance between our hormones, our metabolism, and our body heat it's a testament to the incredible complexity of our bodies. It really makes you think, doesn't it? What other invisible forces, from the food we eat to the stress we feel, are constantly, quietly fine-tuning your internal thermostat right now?